Good evening, Seekers. Welcome back to the Sleep Scholar Archive. Tonight, we continue Book 2, the Book of the Cosmos. In the last chapter, we followed the first light. We watched the early universe cool enough for atoms to form. We watched the cosmic fog clear. We listened for the oldest visible glow in existence, the faint afterimage of the young cosmos. But after that first light, the universe did not immediately fill with stars. For a long time, there was only darkness. No suns, no planets, no galaxies shining in the distance, only vast clouds of hydrogen and helium, drifting through a universe that had become transparent, but had not yet learned how to shine. Tonight, we enter that darkness, and we wait for the first stars to be born. Settle in. The archive is open, the cosmos is dark, and somewhere in that darkness, gravity is beginning to gather the first fires. For a long stretch of cosmic time, the universe was simple in a way that is almost impossible to imagine. There were no constellations to name, no worlds turning around distant suns, no metal, no stone, no dust, no oceans, no mountains, no bodies, no eyes. The universe had expanded, it had cooled, it had released its first light into the distance. But it was still made almost entirely of the simplest things. Hydrogen, helium, a trace of lithium, and silence. If you could have existed there, suspended in that early dark, there would have been very little to see. The first light was already stretching, cooling, and fading into longer, quieter wavelengths, as space itself continued to expand. Around you, there would be gas, thin, cold, nearly featureless, no spiral arms, no glowing nebulae, no star fields. The universe was open, but unlit. And yet, hidden inside that darkness, the future was already moving, because the early universe was not perfectly smooth. In the first light, there were tiny differences. Slightly warmer places, slightly cooler places, slightly denser regions where matter had gathered just a little more tightly than elsewhere. They were not dramatic differences. They were not stars yet. They were not galaxies yet. They were almost nothing. But in a universe ruled by gravity and time, almost nothing can become everything. The slightly denser regions had a little more gravity. Because they had a little more gravity, they pulled more gas toward themselves. And when they pulled more gas toward themselves, they became denser still. And because they became denser, their gravity grew stronger. This is how the darkness began to change. Not suddenly, not violently. It began quietly, through the patient inward pull of matter toward matter. Across the young universe, invisible gathering places began to form. Great clouds of hydrogen and helium drifted inward. The first great structures were not made of stars yet. They were made of possibility. Dark matter helped shape the hidden scaffolding of the early universe. Ordinary matter began to follow those invisible wells of gravity. Gas collected inside them. Clouds thickened. The universe, once nearly uniform, began to gather itself into places. And in those places, the first stars would one day ignite. It is strange to think of a star as something that has to be born. We are used to stars as distant points of light, already complete, already shining. But every star had a beginning. Every sun was once a cloud. Every light was once darkness, collapsing inward. And the first stars were born from the simplest ingredients the universe had. Hydrogen, helium, gravity, time, nothing more. There were no heavy elements yet. No carbon, no oxygen, no iron, no silicon, no dust grains drifting through space. Because there were no older stars. The first generation had to form before anything else could be made. They were the universe's first attempt at fire. These first stars may have been enormous, far larger than most stars we see today. Brilliant, violent, short-lived. Not gentle lanterns, but cosmic furnaces. Born in a dark universe that had never seen starlight before. Their birth would change everything. Before them, the universe was transparent but dark. After them, light would begin to return. New light, local light, starlight. The first stars would open their eyes in the dark. And with them, the universe would begin its long transformation from simple gas into everything that would one day be possible. For now, stay here, at the edge of the cosmic dark age, before the first sunrise, before the first galaxy glows, before the universe has learned the shape of fire. Outside the observatory window, the stars seem eternal. But tonight, Seekers, we remember that even the stars had to begin. Section 2. In the darkness after the first light, gravity worked without hurry. It did not need to glow. It did not need to announce itself. It only needed time. Across the young universe, the smallest uneven places slowly became more important. A region that held a little more matter pulled a little more strongly. Gas drifted toward it. More gas made the pull stronger. The stronger pull gathered still more. Slowly, the invisible map of the cosmos began to deepen. These gathering places were not like the bright nebulae we see in space photographs today. There was no colorful dust, no glowing red clouds, no blue reflection light, no young stars hidden inside them. There were no young stars yet. There was only the dark gas of the early universe, falling into the first wells of gravity. Much of the shape came from dark matter. Dark matter did not shine. It did not form atoms. It did not make chemistry, dust, stone, water, or worlds. But it had gravity. And in the young universe, that was enough. Dark matter gathered first, forming wide, invisible halos. Ordinary matter, the hydrogen and helium gas, began to fall into those halos, collecting inside the hidden structure that dark matter had prepared. The universe was building rooms before it lit the lamps. Inside those early halos, gas moved inward. At first, it was thin and spread out. But as it fell deeper into gravity's hold, it compressed. As it compressed, it grew warmer. The gas began to swirl, collide, and gather into denser clouds. Everything was still dark. But the darkness was no longer empty. It was becoming organized. In one region, a vast cloud grew a little denser. In another, gas folded slowly inward. In another, gravity began to overcome the outward motion of expansion, and a cloud started to collapse under its own weight. This collapse was not simple. As gas fell inward, it heated up. Heat creates pressure. Pressure pushes outward. Gravity pulls inward. A star can only be born when gravity wins. But in the early universe, gravity had a problem. The gas was made mostly of hydrogen and helium, and those simple atoms did not cool easily. Cooling matters because a cloud that cannot release heat resists collapse. It swells, it pushes back, it holds itself apart. Today, star-forming clouds contain heavier elements and dust. They can cool more efficiently. They can break apart into many smaller stars. But the first clouds had no such help. There had been no older stars to make those ingredients. No ashes, no dust, no carbon, no oxygen, no iron. The first clouds had to collapse with almost nothing. Only simple gas, only gravity, only patience. And yet, in some places, that was enough. A small amount of molecular hydrogen may have made the difference. When hydrogen atoms joined into pairs, they could release a little energy. Not much, but enough to help some gas cool. And when the gas cooled, pressure weakened. The cloud could fall inward more deeply. The center grew denser. The center grew hotter. The center became the place where the future was concentrating. Imagine a vast invisible cloud, far larger than any solar system, slowly drawing itself inward in the dark. From the outside, there is no star yet, no bright surface, no golden sphere, only gas, motion, and gravity. But deep inside, the pressure is rising. Atoms are being pushed closer together. The cloud is becoming a core. The core is becoming a furnace. Not lit yet, not alive yet, but close. This is the quiet before the first ignition. The Dark Age was not ending everywhere at once. The first stars did not appear like city lights turning on across the universe. They appeared one by one, in rare, dense places, where gravity gathered enough gas, where cooling allowed collapse to continue, where the center of a cloud became heavy enough to cross the threshold into fire. For most of the universe, darkness remained, but somewhere, in one of those early clouds, a core became dense enough, hot enough, crushed enough. The inward fall continued. The pressure rose, the temperature climbed, and the universe came closer than it had ever been to making a star. Section 3. Deep inside the collapsing cloud, the center grew heavier. Gas continued to fall inward. Layer after layer pressed down on the core. The weight of the cloud became pressure. The pressure became heat, and the heat continued to rise. At first, there was still no true star, only a protostar. A hidden beginning. A dense, hot center wrapped inside a larger cloud of gas. From far away, it would not look like the stars we know. It would be buried in darkness, still gathering itself from the material around it. But inside, something ancient was changing. The more the gas collapsed, the hotter it became. The hotter it became, the more violently the particles moved. Hydrogen atoms, once drifting quietly through space, were now being pushed closer together under enormous pressure. Gravity was no longer only gathering the cloud, it was transforming it. For a star to truly begin, heat and pressure must rise high enough for fusion. Fusion is the deep fire of a star. It is not ordinary burning. A campfire burns because atoms rearrange with oxygen. A star burns in a deeper way. In the heart of a star, hydrogen nuclei are forced so close together that they can join. When they join, they form helium, and a small amount of mass is released as energy. That energy becomes light. That energy becomes heat. That energy becomes the outward pressure that allows a star to stand against its own gravity. This is the balance of a star. Gravity pulls inward. Fusion pushes outward. Between them, a star can live. But before this moment, no star had ever lived. The universe had light before. It had heat before. It had matter, space, and time. But it had not yet made a sun. So, the core kept collapsing. The pressure rose, the temperature climbed. Hydrogen was pushed closer and closer. Then, somewhere in the deep center of one of the first great clouds, the threshold was crossed. Fusion began. The first true star ignited. For the first time since the release of the ancient light, the universe made new light from within itself. Not a fading glow left over from the beginning. Not an echo stretched across all directions, but a living fire, a source, a star. It is difficult to imagine how lonely that first light must have been. There were no constellations around it, no planets circling in its warmth, no nearby spiral arms filled with other suns, no eyes to see it, only the surrounding dark. And yet the darkness was no longer complete. Somewhere, the first star was shining. Its light moved outward into space that had never held starlight before. Photon by photon, the cosmic dark age began to change. The first stars were probably not gentle little lanterns. They may have been enormous, far larger than most stars we see today. Brilliant, violent, short-lived. They burned hot because they were massive. They lived briefly because they burned so fiercely. A small red star can last for trillions of years. A star like our sun can last for billions. But a giant star may spend itself in only a few million years. In cosmic time, that is almost nothing. The first stars may have been brief and furious things, but while they lived, they changed everything around them. Their radiation heated nearby gas. Their light traveled through the dark. Their energy began to reshape the young universe. Before them, the cosmos was mostly simple gas and hidden structure. After them, the universe had begun the long work of complexity. A star is not just a flame. It is a machine of transformation. It takes hydrogen and begins making helium. It takes gravity and turns it into heat. It takes pressure and turns it into radiance. It takes darkness and gives it a center. The first stars were the first engines, the first furnaces, the first lamps in the cosmic dark. And as more clouds collapsed across the young universe, more lights began to appear. Not everywhere, not all at once, but slowly. One star, then another, then clusters, then scattered islands of fire. The universe was beginning to wake. Outside the observatory window, the stars seemed calm, but their origin was not calm. Every star is gravity pressing matter until matter answers with light. And the first stars were the first answer. The first proof that the darkness could change. Section 4. The first stars did not shine in a universe like ours. They were not surrounded by familiar constellations. They were not born inside spiral galaxies filled with older suns. They did not rise over planets. They did not warm oceans. They did not shine on stone, ice, trees, or living eyes. They burned alone, or in small early groups, inside a universe that was still mostly dark. This is why astronomers give them a special name, Population 3 stars. Not because they were third in time, but because of the way stars are classified by what they contain. The stars around us today contain traces of many elements: carbon, oxygen, silicon, iron, gold, tiny fingerprints of earlier stars that lived and died before them. Our sun carries those fingerprints too. It is not a first star. It was born much later, from material already enriched by ancient stellar deaths. But the first stars had none of that. They were almost pure. Hydrogen, helium, a faint trace of lithium. Nothing more. They were made from the original material of the universe. The first clean fire. And because they lacked heavier elements, they behaved differently from stars today. Heavier elements help gas cool. Dust helps gas cool. When gas cools, it can break apart into smaller pieces, and those pieces can become smaller stars. But the first gas clouds could not cool easily. They held heat. They resisted fragmentation. So instead of forming many small stars, some of those early clouds may have formed enormous ones. Great blue-white furnaces, brilliant beyond imagination. Hotter, heavier, and more violent than most stars we see now. They may have poured out intense ultraviolet light, strong enough to change the gas around them. Around each newborn star, the surrounding hydrogen began to feel the violence of light. Photons struck atoms, electrons were stripped away. The quiet neutral gas became ionized. A bubble of transformed space grew around the star. One bright region inside the dark, then another, then another. This was the beginning of cosmic dawn. Not a sunrise everywhere at once, not a soft golden morning, but scattered flames opening holes in the darkness. The universe was still vast, still mostly empty, still mostly unlit, but the first stars were carving light into it. Their radiation pushed against nearby gas. Their heat changed the clouds that had made them. Their presence made it harder for some new stars to form nearby, while also helping shape the next places where stars might gather. Light was no longer only a memory from the beginning. Light had become active. It had become local. It had become a force moving through the young cosmos. And yet, there was still no one there to witness it. No astronomer, no creature, no eye, no mind. The first dawn happened without an audience. The universe changed before there was anyone to call it beautiful. That is one of the strange truths of cosmic history. Most of the important things happened in silence. The first atoms formed in silence. The first clouds gathered in silence. The first stars ignited in silence. And still, everything that came later depended on them. The first stars were not just lights in the dark. They were the beginning of a chain. Their birth changed the gas around them. Their heat disturbed the early clouds. Their radiation opened the first bright wounds in the Dark Age. And inside their cores, something even more important was beginning. Hydrogen was becoming helium. Later, in the deepest heat of massive stars, heavier elements would begin to form. The universe was learning a new language. Not just expansion, not just cooling, not just gravity, but chemistry, transformation, interior fire. The first stars were short-lived compared with the deep age of the cosmos. But they did not need to live long to matter. Some things change the future quickly. A match does not last long. A spark does not last long. A first word does not last long. But after it happens, silence is no longer the same. The first stars were like that. Brief, brilliant, necessary. They opened the dark. They began the making of new elements. They prepared the universe for galaxies, planets, and eventually, the strange possibility of observers looking back. From the quiet observatory, we look at stars as if they are peaceful. But the first stars were not peaceful. They were the universe's first great act of transformation. And already, from the moment they began to shine, their deaths were approaching. Section 5. The first stars were born brilliant, but they were not built to last. Their size made them powerful. Their power made them unstable. Their heat allowed them to shine with a force the young universe had never seen before. But that same heat also meant they were burning through their fuel quickly. A smaller star can live slowly. It can spend its hydrogen carefully, shining for billions or even trillions of years. But a massive star lives like a storm. It burns hotter. It shines brighter. It consumes itself faster. The first stars may have been some of the most massive stars the universe ever made. And because of that, their lives may have been brief. Not brief to us. A few million years is longer than human history many times over. But to the universe, a few million years is almost a flicker. A candle flame in a cathedral. A spark inside the dark. Deep inside those first stars, fusion continued. Hydrogen became helium. The core changed, the balance shifted. A star survives by balancing two forces. Gravity pulls inward, fusion pushes outward. As long as fusion can answer gravity, the star holds itself open. But a star is not an endless fire. Its fuel changes, its core evolves. The first stars began with hydrogen, the simplest element. Hydrogen joined into helium. In the hottest and most massive stars, helium could later become heavier elements. Carbon, oxygen, neon, magnesium, silicon. The star became a furnace with many rooms, each layer burning differently, each layer making something new. This is one of the most beautiful facts in all of astronomy. The universe did not begin with the ingredients for life. It began mostly with hydrogen and helium. The rest had to be made. The carbon in living cells, the oxygen in breath, the calcium in bone, the iron in blood, the silicon in stone. These were not present in the beginning. They had to be forged. And the first stars were among the first places where that forging could begin. Inside them, the universe started to become chemically complex. It was no longer only expanding and cooling. It was creating. But the creation came with a cost. In the most massive stars, fusion eventually builds heavier and heavier elements near the core. Each stage lasts for a shorter time than the one before it. Hydrogen burning can last a long time. Helium burning is shorter. Carbon burning is shorter still. Near the end, the star races through its final stages with terrifying speed. The center becomes heavier. The pressure becomes more extreme. The balance becomes harder to maintain. And eventually, for a massive star, the core reaches a limit. Fusion can no longer save it. Gravity begins to win. The inward pull that once gave birth to the star now returns as its destroyer. The core collapses. Matter falls inward with unimaginable force. The outer layers, still full of heat and motion, crash and rebound. The star tears itself apart, a supernova, a death so bright it can outshine entire galaxies. For the first stars, this death was not just an ending, it was a delivery. The elements made inside the star could not help the universe while they remained trapped in the core. They had to be released. They had to be thrown outward. They had to be scattered into space. The explosion carried them into the surrounding dark. Carbon, oxygen, silicon, iron. The first ashes of stars. The first enrichment of the universe. Before this, the gas between stars was almost pure. After this, it was changed. The dark was no longer empty gas. It held memory. It held remains. It held the ingredients of futures that did not exist yet. The death of a first star seeded the clouds around it. Those clouds would one day collapse again. But the next stars would not be exactly like the first. They would be born from gas that had been touched by death. Gas that could cool better. Gas that carried heavier elements. Gas that could fragment into smaller stars. The universe was learning from its own explosions. It is strange to think of creation this way. Not as a gentle process. Not as a clean beginning, but as inheritance through destruction. The first stars had to die, so later stars could be different. They had to break open so the universe could become richer. They had to scatter themselves so that future worlds could someday form from their remains. Outside the observatory window, the stars seem distant and still. But every quiet point of light belongs to a violent family tree. Every later star carries history. Every world is made from old fires. And somewhere, long before Earth, long before the sun, long before there was anyone to ask where we came from, the first stars began giving the universe its first ashes. Section 6. After the first stars died, the universe was no longer the same. Their light had opened the darkness. Their explosions had shaken the young cosmos, and their ashes had entered the gas between stars. For the first time, space held more than the original ingredients. Not much, only faint traces. Carbon, oxygen, silicon, iron, scattered outward into the dark. But even a little enrichment changed everything. The early universe had begun almost simply. Hydrogen, helium, gravity, time. Now something new had been added. Memory. The next clouds of gas were no longer untouched. They carried the remains of earlier fires. And because they carried heavier elements, they could cool more easily. This mattered more than it may sound. A cloud that stays warm resists collapse. Its pressure pushes outward. It holds itself apart. But a cloud that cools can fall inward more deeply. It can fold into smaller regions. It can break apart into fragments. And each fragment can become its own star. The first stars may have been enormous because the original gas could not cool well. It resisted breaking into many smaller pieces, so gravity gathered great masses into a few powerful fires. But enriched gas behaved differently. With carbon, oxygen, and other heavier elements mixed into it, the gas could release heat more efficiently. Dust, when it began to form, helped even more. The universe was learning how to make smaller stars, longer-lived stars, stars more like the ones that would later fill galaxies. One generation had changed the conditions for the next. This is how cosmic history moves, not as a clean straight line, but as inheritance. Gas became stars, stars became furnaces, furnaces became explosions, explosions became enriched gas, and enriched gas became new stars. Birth, fire, death, ashes, return. Slowly, this rhythm spread through the young cosmos. More clouds collapsed, more stars ignited, more stars died, more elements were released. The darkness was still enormous, but it was no longer simple. It had been touched by light. It had been seeded by death. It had begun to remember. And gravity kept gathering everything into larger structures. The first stars did not remain alone forever. They formed inside small early systems, inside dark matter halos where gas had collected. Those halos merged with other halos. Gas streams fell inward. Young stars gathered into clusters. Clusters gathered into larger islands of matter. The first galaxies began to take shape. They were not calm spiral galaxies like the Milky Way. Not yet. They were smaller, rougher, messier. Young islands of light inside a much larger darkness. In them, the universe became active. Stars formed, stars died, gas collapsed, radiation poured outward, elements mixed. The first galaxies were not finished cities. They were settlements of fire, rough beginnings, places where gravity, gas, and starlight were learning how to live together. This was Cosmic Dawn. The name sounds gentle, but Cosmic Dawn was not one smooth sunrise. It was patchy, uneven, scattered. Here, a star, there, a cluster. Somewhere else, a young galaxy glowing for the first time. Around these first lights, radiation changed the gas nearby. Energetic light stripped electrons from hydrogen atoms, opening bright bubbles in the surrounding dark. Bubble by bubble, the old cosmic darkness began to loosen. The universe was becoming luminous. Still, there were no planets like Earth. No oceans, no forests, no animals, no living eyes, only preparation. The universe was making ingredients before it made worlds. It was building chemistry before it built life. This is why the first stars matter so much. Without them, the universe would have remained too simple. No carbon for life, no oxygen for water, no silicon for rock, no iron for planetary cores, no dust, no stone, no Earth, no us. The first stars are gone now. But their work is still here. In planets, in oceans, in bodies, in breath, in every eye that looks back into the dark and wonders where the light began. Section 7. As the first stars and galaxies continued to form, their light began to change the space around them. This was not only illumination, it was transformation. The universe had already become transparent once, long before the first stars, when atoms formed and the first light was released. But now something different was happening. The gas between the early stars was mostly neutral hydrogen. Quiet, thin, spread across the dark spaces between growing structures. When the first stars ignited, their light poured into that gas. Some of that light was gentle. but some of it was fierce. Ultraviolet radiation carried enough energy to strike hydrogen atoms and tear their electrons away. The atoms were split apart. The gas became ionized. A star would form inside the dark. Then a bubble of ionized gas would grow around it. A young galaxy would burn. Then a larger bubble would form. Across the universe, these bubbles began appearing in the darkness. Not everywhere at once, not evenly, but slowly, region by region, the old neutral gas was changed. This era is called reionization. It is one of the great transitions in cosmic history. First, the universe was hot and ionized. Then it cooled, atoms formed, and the first light escaped. Then came the Dark Ages. Then the first stars appeared, and their light began ionizing the universe again. The cosmos was being rewritten by its own newborn fires. Imagine the dark universe as a vast ocean of quiet hydrogen. Now imagine small lights appearing within it. Each light pushes outward. Each light opens a clearing. Each clearing grows. Some bubbles remain small. Some meet other bubbles. Some merge into larger regions of transformed space. Over time, the darkness becomes full of openings. The first galaxies were not only collections of stars, they were engines of reionization. They poured radiation into the surrounding universe, altering the very gas between galaxies. Light was no longer trapped inside stars. It was reaching outward, changing matter, changing space, changing the future. This did not happen quickly by human standards. It unfolded over hundreds of millions of years. But compared with the full age of the universe, it was still a kind of dawn. Long, uneven, beautiful, violent. There is something strange about a dawn without a horizon. On Earth, morning comes from one direction. The sky brightens, the edge of the world glows, light climbs over the land. But cosmic dawn came from everywhere and nowhere. It did not rise, it ignited. A star here, a cluster there, a young galaxy farther away, then more, until the universe was no longer only dark space with scattered fires. It was becoming a web of light. The first galaxies grew inside the hidden framework that gravity had been building since the beginning. Dark matter shaped the great structure. Gas followed. Stars formed. Galaxies gathered. Light escaped. The universe began to reveal the pattern it had been carrying in silence. This is where the story begins to feel familiar. Not because the universe was like ours yet. It was not. There were still no stable solar systems like our own. No blue planets. No quiet moons. No familiar night sky. But the ingredients of the familiar universe were beginning to appear. Stars, galaxies, heavy elements, radiation, dust, cycles of birth and death. The cosmos was no longer a simple place. It had become historical. One thing led to another. The first light left its pattern. Gravity deepened the pattern. Stars formed inside it. Stars changed the gas. Stars died and enriched the dark. New stars formed from what remained. Galaxies gathered the process into larger homes. The universe was beginning to have memory on every scale. In the gas, in the stars, in the first galaxies, in the widening spaces between them. Everywhere, the past was becoming material. That is what makes the first stars so important. They did not simply appear and vanish. They changed the rules for everything after them. Before them, the universe could only gather simple gas. After them, the universe could begin making complexity. Before them, darkness was the condition of space. After them, darkness became something light could enter. The Dark Age did not end because one star turned on. It ended because enough stars turned on. Enough galaxies formed. Enough light escaped. Enough bubbles grew and merged. Slowly, The universe passed from hidden preparation into visible structure. And in that passage, the cosmos became closer to the one we recognize. Still ancient, still young, still without Earth, but no longer silent in the same way. The first stars had opened the dark. The first galaxies were widening the opening. And light, once rare and lonely, was beginning to travel through a universe that could hold it. Section 8. The first stars are gone now. No telescope can turn toward the nearby sky and find one still burning. They lived too early. They burned too fiercely. They died too long ago. And yet, the universe keeps records. Not in books, not in monuments, but in light. When we look into space, we are also looking backward in time. The farther away we look, the older the light becomes. Distance becomes memory. Light carries the past to us. So when astronomers search for the first stars, they are really searching for the oldest reachable messages. They look for galaxies so distant that their light has traveled almost the entire age of the universe. They look for faint red smudges, stretched by expansion, softened by time, and almost swallowed by the darkness between galaxies. The first stars themselves may remain hidden. They may have lived and died before we could ever see them clearly. But their descendants left clues. The first galaxies carry hints of them. Ancient gas carries hints of them. The chemical fingerprints of later stars carry hints of them. The universe is not silent about its past. It only speaks slowly. One of the great clues is redshift. As the universe expands, light traveling through it is stretched. Blue light becomes redder. Visible light may stretch into infrared. The farther the light has traveled, the more it has been stretched by the growth of space. So the oldest galaxies do not usually arrive to us as ordinary, visible light. Their light has been pulled into longer wavelengths. To study them, astronomers need instruments that can see deep into the infrared. They are not only looking across distance, they are listening to stretched time. A tiny point of infrared light may be a young galaxy from the cosmic dawn. A faint glow may be a place where early stars were forming. This is a strange kind of archaeology. On Earth, archaeology digs downward, layer by layer. Dust, stone, bones, ashes, buried cities. In astronomy, we dig outward. Farther distance, older light, earlier structures, deeper time. The sky becomes an excavation. Every faint galaxy is a shard. Every ancient photon is a messenger. And the first stars remain among the most mysterious ancestors in that record. They may have been too massive and too short-lived to survive into the present. They may have exploded so completely that nothing recognizable remained. They may have formed in places too faint for us to see directly. But their influence is everywhere. If a distant ancient galaxy contains heavier elements, then earlier stars must have made them. If gas has been ionized, then light must have transformed it. If later stars were born smaller and longer lived, then something before them enriched the clouds. The first stars are known partly by absence and partly by inheritance. They are like a vanished fire whose warmth changed the room. We may never see the very first one as a clear object. No single golden sphere labeled beginning. The truth is more subtle. We find the first stars by studying what came after them. We look for their ashes. We look for their effects. We look for the universe becoming different because they existed. That is often how origins work. The beginning is not always preserved in a clean form. Sometimes the beginning survives only in consequences. In the quiet observatory, this is worth remembering. The cosmos does not give up its earliest memories easily. It hides them behind distance. It stretches them with expansion. It buries them inside later generations. But still, the record remains. In the faintest galaxies, in the oldest light, in the elements inside stars, in the chemistry that eventually made planets. The first stars are not visible as familiar points in our night sky, but they are present in the story of everything that followed. They are present in the fact that galaxies could grow, in the fact that gas could cool, in the fact that worlds could form from enriched clouds, and in the fact that we can sit here now, beneath later stars, asking about the first ones. We are not separate from that ancient dawn. We are made from a universe that learned how to shine. The first stars were the beginning of that lesson. Section 9. The first stars were not the end of the beginning. They were the beginning of structure. Once they appeared, the young universe became a place of motion, feedback, and change. Light pushed outward, gas fell inward, stars formed, stars died, ashes mixed with clouds. And gravity continued drawing matter into larger and larger homes. The first galaxies grew from small beginnings. They were not born as giant spirals. They did not begin with graceful arms, quiet disks, and billions of organized stars. They began as rough gatherings. Dark matter, gas, young stars, explosions, motion, fragments merging with fragments. Small halos came together. Gas streams flowed through them. Stars gathered in bright knots. Supernovae stirred the surrounding material. The first galaxies were alive with turbulence. They were young, irregular, and unfinished. They were less like calm cities and more like fires being built in the wind. And yet inside them, the future was taking shape. Because galaxies are more than collections of stars. They are places where cosmic history can repeat and deepen. A galaxy holds gas long enough for new generations of stars to form. It gathers the ashes of dead stars. It mixes elements through clouds. It gives gravity a larger stage. Inside galaxies, the universe learned how to recycle itself. The death of one star could enrich the birth cloud of another. The explosion of one generation could prepare the next. The first stars had scattered heavy elements into the dark. The first galaxies gathered those elements, mixed them, and gave them somewhere to continue. Slowly, the universe became less simple. More stars formed. Some were massive and brief. Some were smaller and longer lived. Some may have survived for billions of years. The range of stars began to widen. The universe was no longer only making enormous first fires. It was learning variation, size, color, lifetime, chemistry. The first galaxies became workshops of difference. In one place, gas collapsed quickly and made bright clusters. In another, supernovae blew material outward. Elsewhere, enriched clouds cooled and fragmented into smaller stars. The cosmos was becoming layered. No longer only the story of the beginning. Now it was the story of consequences. This is one of the quiet truths of the universe. Nothing important stays isolated. A star changes the cloud around it. A cloud changes the galaxy around it. A galaxy changes the space around it. The first stars changed the gas. The first galaxies changed the dark. And together they helped build the universe we now recognize. Not all at once, not smoothly, but patiently, through collapse, through fire, through death, through return. If we could drift near one of those first galaxies, it would not look peaceful. It might glow in uneven patches. Young stars would burn fiercely in some regions. Clouds of gas would twist under gravity. Explosions would send shockwaves through nearby material. Radiation would pour outward into the spaces around the galaxy. There would be beauty there, but not gentleness. This was creation still in its rough form. A universe testing its own possibilities. A universe discovering what matter could become. And far away from those first young galaxies, the rest of space remained dark, cold, and thin. The cosmic dawn did not erase the night immediately. The night lingered between the lights. It lingered between the growing galaxies. It lingered in the great spaces where gas had not yet gathered into stars. But the direction had changed. The universe was no longer moving only from heat into cold. It was moving from simplicity into structure, from darkness into scattered light, from original gas into chemistry, from chemistry into the possibility of worlds. The first galaxies were the first great libraries of this process. They stored stars, they stored gas, they stored the ashes of explosions, they stored the growing memory of the cosmos. And eventually, much later, galaxies like these would merge, grow, and change. They would become larger systems. They would form disks, halos, clusters, and spiral arms. They would become homes for later stars. And around some of those later stars, planets would form. Not yet, not here, not in this earliest dawn. But the path had opened. The universe had crossed from preparation into construction. The first stars had lit the dark. The first galaxies had gathered the light. And somewhere in that gathering, the long road toward familiar skies had begun. Section 10. The first stars are gone, but their inheritance did not disappear. It moved outward. It mixed with gas. It entered the first galaxies. It became part of the material from which later stars would form. This is one of the deepest ideas in the story of the cosmos. The universe does not simply replace one age with another. It carries its earlier ages forward. The first stars lived briefly, but they changed the gas around them forever. Their light helped end the Dark Age. Their explosions seeded the young universe with heavier elements. Their presence made later stars possible in a new way. Before them, the universe could gather. After them, the universe could build. The difference is enormous. A universe of only hydrogen and helium can make stars, but it cannot easily make rocky worlds. It cannot easily make dust. It cannot easily make oceans, mountains, bodies, or breath. For those things, the universe needed enrichment. It needed carbon, oxygen, silicon, iron, and many other elements made in stars, or released in the violence of stellar death. The first stars began that long process. They were not enough by themselves to make Earth. Many generations would follow. Many stars would be born, live and die. Many clouds would collapse and be enriched again. Many galaxies would grow and merge. But the first stars opened the path. They turned the universe from a place of original gas into a place where chemistry could deepen. Slowly, the ashes of stars entered new clouds. Those clouds formed new stars. Around some later stars, disks of gas and dust began to spin. Inside those disks, grains could stick together. Tiny pieces could become larger pieces. Larger pieces could become stones. Stones could become worlds. This did not happen at the beginning. It took time. It took repeated cycles of fire and return. But the beginning of the possibility was here, in the first generation of stars. That is why their story feels so close, even though it happened so far away. They are not just ancient objects, they are part of our ancestry. Not in a simple, direct line that can be drawn neatly through space, but in the deeper sense that everything familiar required what they began. The iron in a planet, the oxygen in water, the carbon in living things, the calcium in bone, the dust in a nebula, the stone beneath a future sky. All of it belongs to the long aftermath of stars. The first stars were the first step in that transformation. When we say that we are made of stardust, it is easy for the phrase to become too familiar. It can sound like a decoration, a pretty thought, but it is not only poetry, it is history. The atoms in our bodies are not separate from the story of the universe. They were made, scattered, gathered, and remade across cosmic time. Matter remembers. Not consciously, not like a mind, but structurally, chemically, physically. Every element carries the history of how it could exist. Hydrogen remembers the beginning. Carbon remembers stellar interiors. Iron remembers violent endings. Dust remembers cooling clouds. Planets remember the gathering of ancient debris. And life, when it finally appears, is the universe arranged in such a way that it can wonder about itself. That is still far ahead in our journey. For now, there are no people, no Earth, no Sun, no Milky Way as we know it. Only the first stars, the first galaxies, and the first enrichment of the dark. But the direction has changed. The universe now has a path toward complexity. It has light, it has structure, it has chemical memory. The cosmic dark age is giving way to a young, restless dawn. Outside the observatory window, the stars may seem like distant decorations, but each one belongs to a history of pressure, collapse, ignition, and return. Each one is part of the long argument between gravity and light. The first stars began that argument in its most ancient form. They gathered from darkness. They burned with terrible brilliance. They died into space. And in doing so, they gave the future something it did not have before. Ingredients, possibility, a richer kind of night. The universe would never again be only what it had been. Section 11. From the quiet observatory, it is easy to look at the stars as if they are permanent. They seem fixed, calm, almost outside of time. But the story of the first stars reminds us that every light has a history. Every star was once a cloud. Every cloud was once scattered gas. Every element was once part of some older transformation. Nothing in the cosmos simply appears fully formed. Everything arrives through process, through gathering, through pressure, through fire, through loss. The first stars were not the stars we know best. They were not the sun. They were not the familiar points in our night sky. They were earlier than familiarity, earlier than worlds, earlier than mature galaxies. They belonged to a universe still learning what it could become. And because they lived so early, they are difficult to see directly. Their light has traveled through nearly the entire history of the universe. Their traces are faint. Their bodies are gone. Their explosions have faded into distances we can barely reach. But their importance remains. They changed the darkness into something that could hold futures. They changed simple gas into enriched gas. They changed the young universe from a place of preparation into a place of becoming. Before the first stars, the cosmos had structure, only in hidden form. The seeds were there, the gravity was there, the matter was there. But after the first stars, the universe had active engines, it had furnaces, it had sources of new light, it had the first makers of heavier elements. And once that began, the story could not return to what it had been. The universe had crossed a threshold. This is one of the quiet patterns of cosmic history. A threshold may take millions of years to reach. It may happen slowly. It may be scattered across impossible distances. But after it is crossed, everything after it belongs to a new world. The first atoms were a threshold. The first light was a threshold. The first stars were a threshold. Each one opened a door the universe could not close again. And the door opened by the first stars led toward everything that followed, toward galaxies growing larger, toward later generations of stars, toward clouds rich enough to make dust, toward disks around young suns, toward planets, toward oceans, toward life, toward minds capable of looking back. None of that existed yet, not here, not in this chapter of time, but the path had begun. It is strange to think that the universe could prepare for things it did not know were coming. There was no intention in the first stars, no plan, no desire to make worlds. They did not burn for us. They did not die for us. They simply followed the laws of matter under gravity. And yet, from those laws came inheritance. From collapse came light. From light came transformation. From death came enrichment. From enrichment came possibility. The cosmos does not need to intend beauty in order to become beautiful. It does not need to plan meaning in order to make meaning possible. It only needs time, matter, and change. That may be one of the deepest comforts of astronomy. The universe is not static. Even darkness is not final. The Dark Age lasted for ages, but it was not empty failure. It was preparation. The first stars did not erase the dark all at once. They entered it, they changed it, they left something behind. And slowly, what they left behind became part of everything else. In the archive, we can imagine the shelves of cosmic history stretching farther than sight. The first light rests on one shelf, the Dark Age on another, the first stars on another. But in truth, these things are not separate. Each shelf leans into the next. Each chapter carries the last inside it. The first stars carried the tiny unevenness of the first light. Later, galaxies carried the ashes of the first stars. Future planets would carry the ashes of many generations. And eventually, much later, living beings would carry those planets in their bodies. Stone, water, blood, breath, thought. All of it is part of the same unfolding. The first stars are gone, but gone does not mean erased. In the cosmos, disappearance can become inheritance. A star can vanish and still change the future. A fire can die and still leave warmth in the walls of time. The first stars did not remain in the sky. They became part of the sky. They became part of the galaxies. They became part of the long chemical memory from which later worlds would form. And so, when we look out into the night, we are not only looking at lights, we are looking at descendants. We are looking at the children of older fires. We are looking at a universe that remembers how to shine. Section 12. And so, Seekers, we have followed the universe into one of its first great awakenings. We began in darkness, not empty darkness, not meaningless darkness, but a darkness filled with waiting. The first light had already been released. The cosmic fog had cleared, atoms had formed, space had become transparent, but the universe was still without stars. It had not yet made suns. It had not yet made galaxies. It had not yet made worlds. Only the simplest gas drifted through the widening dark. Hydrogen, helium, a faint trace of lithium. And hidden within that simplicity, the future waited. Tiny, uneven places in the early universe began to deepen. Gravity gathered gas into invisible wells. Dark matter shaped the first hidden scaffolding. Clouds thickened, centers warmed, matter fell inward. And in rare places, after long ages of silence, the pressure became great enough. The heat became fierce enough. The first stars ignited. For the first time, the universe made new light from within itself. Not the ancient afterglow of the beginning, not the fading memory of the first light, but starlight, local light, living fire. Those first stars were likely enormous, brilliant, violent, short-lived. They were born from a universe that had almost nothing to give them except simple gas, gravity, and time. And still, they burned. They opened the Dark Age. They heated the gas around them. They carved bright regions into the young cosmos. They began the slow dawn that would eventually fill the universe with stars and galaxies. But their lives were brief. The same mass that made them powerful also made them unstable. They burned quickly. They changed quickly. They died violently. And in their deaths, they gave the universe something it had never had before. Heavier elements, carbon, oxygen, silicon, iron, the first ashes of stars, the first chemical memory of the cosmos. Before them, the universe could make light. After them, the universe could begin making worlds. That is the strange beauty of the first stars. They did not last, but they mattered. They vanished, but they left inheritance. They died, but their deaths made the future richer. From their remains came later clouds. From later clouds came later stars. From later stars came more elements, more dust, more structure, more possibility. The universe began to recycle itself. Gas became stars. Stars became fire. Fire became ashes. Ashes became gas again. And slowly, through that ancient rhythm, the cosmos became less simple. The Dark Age gave way to cosmic dawn. The first stars gathered into early clusters. The first galaxies began to form. Light spread in bubbles through the old neutral gas. The universe, once quiet and unlit, became active, changing, remembering, becoming. And still, all of this happened before Earth, before the sun, before oceans, before mountains, before living things, before any eye could look up and call a star beautiful. The first stars did not shine for us. They did not know us. They did not intend anything. And yet without them, there would be no us at all. No carbon for life, no oxygen for water, no iron for blood, no stone beneath a future sky, no night in which a mind could wonder where the light began. Outside the observatory window, the stars seem quiet now. They seem distant and still. But tonight, we have remembered that every star belongs to a deeper story. Every light was once darkness. Every sun was once a cloud. Every world was once scattered material. And every future begins somewhere before it can be recognized. The first stars are gone now, but gone does not mean lost. Their work continues in every later generation, in every galaxy, in every planet, in every body made from ancient elements, in every breath drawn beneath a younger sky. Tonight, the archive has opened the chapter of the first fires. The universe has crossed from darkness into starlight. In the next chapter, we will follow those first lights as they gather into larger homes. The first galaxies, the first great islands of stars, the beginning of structure on a scale the cosmos had never known before. But for now, rest here. The Dark Age is ending. The first stars have burned. Their ashes are drifting into the future. The book remains open. The cosmos is still unfolding. Good night, Seekers. Sleep well.